Well, hello everyone, and welcome to today's Google Cloud Next session during Cloud AI Week. My name is Addison, and I'm joined by my colleague Phil. We're both members of the Kaggle competitions team, and we're excited to speak with you today specifically about TPUs and TensorFlow on Kaggle. But first, what's Kaggle? Historically, Kaggle has become synonymous with machine learning competitions, but it's really much more than that. Kaggle is a data science platform. Over 5 million data scientists from all over the world come to Kaggle to not only participate in machine learning competitions, but to learn data science, build their skills, polish their portfolios, and share data sets and code. It's truly an incredibly exciting community. Now, my job at Kaggle is to run machine learning competitions, and they run the gamut. Right now, we have 17 competitions running, ranging from understanding bird sounds, predicting lung function decline, classifying melanoma, NLP challenges, and even a bot building simulation competition, among many others. We recently wrapped up a competition with a $1 million prize to detect deepfakes in videos. We had competitions recently with both the NCAA and the NFL, and even an abstract reasoning challenge with Francois Chalet. And by the way, if you haven't seen his recent paper titled On the Measure of Intelligence, it's pretty amazing. I really should encourage you to check that out after this session. But basically, if you're interested in data or machine learning in any form or fashion, we've likely got a competition that will excite you. And really, one of the most exciting elements of Kaggle is that as the home of data science, professionals, hobbyists, thought leaders, and academics will come to Kaggle to test new theories, technologies, and potential advancements in the state-of-the-art and machine learning. Now, we've been very fortunate to witness the birth or the spread and dissemination of many of the leading data science techniques from back when random forest decision trees kind of took over to light GBMs, XGBoost, and the introduction of libraries like Keras. So what better community to introduce great technologies like TensorFlow and TPUs than through Kaggle competitions? And the Kaggle community is filled with data scientists who are eager to experiment and quickly uncover the benefits and shortcomings of newly introduced products and methodologies. And the Kaggle competition can provide a structured and engaging format to test them out. And specifically for TPUs and TensorFlow, our competition platform allows us to host really large data sets and to offer both time and resource constrained formats that can help truly capture the power and understand the benefits of these particular tools. So I'd like to check out the latest TensorFlow edition, as we're calling it 2.x, as they continue to be updated on the Kaggle platform. Especially with GPU or TPU, Kaggle makes it easy. You can see from the list on this slide that we've eliminated a lot of the obstacles to making TensorFlow 2.x build your models fast, and with next to no specialized code. No provisioning of the right kind of VM, no setup, and we already have data sets that are ready to go. Our cloud notebook platform removes the burden of needing to reconcile versions or libraries or packages across collaborators, so sharing and iterating is a breeze. And finally, we even provide a weekly allotment of TPU and GPU time at no cost to our users all over the world. And the integration benefits afforded to TensorFlow also apply to TPUs. They're directly accessible from our Kaggle notebooks without any additional setup. We have generous data sets that are accessible via Google Cloud Storage that allow for efficient data access. 30 hours of TPU use per week are granted to each user. We've even hosted 5 competitions just in the last 6 months aimed at these particular tools. Most recently, we hosted a competition that was TPU-centric with the Google team Jigsaw that was seeking to evaluate and classify toxic comments on Wikipedia. We also just launched a competition called Contradictory, My Dear Watson, which seeks to use TPUs and natural language processing to evaluate grammar. But today we want to look specifically at our first 2 competitions that introduced TPUs to over 5 million data scientists. First being TensorFlow 2.0 question answering, and the second being one on flower classification. Now, TensorFlow is already very heavily used in our competitions. It's currently being used in all of our running competitions, but in the past few months, we've run 2 TensorFlow competitions. As I mentioned, this one on top being a question answering NLP competition built around the launch of TensorFlow 2.0, and a new competition for image classification that introduced TPUs for the first time to our platform. We already have tens of thousands of people using TensorFlow 2.x right now to solve problems, and 3 of the top solutions in the question answering competition ended up using TensorFlow and TPUs. And so next thing I want to do is let's dive into some of the code. Let's look at some of the code right now that will build a model on Kaggle for our competition to classify flowers on CPU, GPU, and TPU with no changes. So Phil, I'm gonna hand it over to you to walk through some of the code for these competitions.
Thanks, Addison. We start off simple by importing TensorFlow 2 and the Kaggle datasets library. The rest of the code here does a bit of magic. It figures out what kind of accelerator is attached to your VM and allows us to automatically parallelize your model building. This will return an appropriate strategy whether you're using a V3 TPU or a simple CPU VM. Basically, this code asks for a TPU, and if it gets one, it connects to it and sets it up. If it can't get a TPU, it sets it up as well. The rest of the code in these slides is entirely accelerator agnostic. Normally, outside of Kaggle and Colab, you'd need to provision this TPU for usage and do some other setup. But on our platform, that's not necessary. Just select the TPU from a dropdown and go. Now we load up our competition dataset. It's provided in sharded TF record format for fast loading. We use multiple files to provide enough data streams to maximize the TPU's throughput. First, we get the path to those TF record files and pass it to TensorFlow. Then set some parameters for our training and validation sets, shuffling our training set, batching both sets for optimal performance, setting our training set to repeat so it'll loop back around with each epoch. We'll pass these into our model, and TensorFlow will access these TF record files while the model is building. The end result of this process is that we have datasets ready to run in our accelerator of choice. This code does some heavy lifting. Here, we load up VGG16 for some transfer learning, and then define our model by adding a global average pooling and output layer on top of that. Note the width strategy.scope block. That's basically saying, hey, whichever type of acceleration strategy you're using here, this is the process to parallelize. Now our model will be compiled and trained on the accelerator we've chosen. Note again that this same code will run on CPU, GPU, or TPU. As long as we identify our distribution strategy, TensorFlow 2 automatically handles putting this model in the right place and building it. After this, we compile our model with our choice of optimizer and loss, pass the training and validation sets from the previous slide into it, and start the model fitting process. Making some flower predictions is easy after this. We load up our test data set using the same type of code that we use to load the training and validation sets. Once again, this results in data that makes the best use of our TPU. Then we run model.predict, transform our predictions into the right form, and write our predictions out in a format that Kaggle can read. With a few tweaks and a few more epochs, this model can actually score pretty well. I'll finish the code section with some of the fun flowers that our model has made predictions on. You can see that some are right, they've got a little OK above them, and some are wrong. If you're interested, you're more than welcome to drop by the Pedals to the Metal competition and beat these results. That won't be hard, but it will probably be fun. And now, Addison, back to you.
Thanks, Phil. As Phil demonstrated in his code review, using TPUs on Kaggle is a super easy way to get used to TPUs. In the flower classification competition that Phil highlighted, we had over 24,000 TPU using sessions by Kaggle users, and a very small amount needed any amount of help to get started. Thanks to some getting started work done by some members of the team, over 80% of users needed no help to begin using TPUs. As you can see in the screenshot of top Kaggle notebooks in the flower classification competition, users quickly created and shared their own TPU-based notebooks and began to train each other with discussion topics and highly upvoted notebooks. Many of these top notebooks came from Kaggle's highest ranked Grandmaster users, and it's really exciting to see the data science community very quickly learning themselves so they can then quickly teach others. So let's highlight some very specific outcomes of this competition. In a Kaggle notebook, users can elect to use a CPU, GPU, or TPU like Phil mentioned. So we picked 2 of the top performing models using each TPUs and GPUs. They each use effectively the same code. The TPU model trained on 25,000 images in 1 hour and 15 minutes. And that same model would run out of memory when they try to flip it over to GPUs. The comparative GPU model took 5 hours to train those same 25,000 images, but they had to be able to reduce size. And in the end, the accuracy still didn't prove competitive with the TPU model. Now, prior to this competition, there have been some slight murmurings of TPUs, but once the first competition was launched in February of this year, you can see the large jump in discussion forum mentions per month about TPUs, and it continued to rise. Now, as we've introduced more competitions, including a competition designed to help introduce TPUs to the uninitiated, we're looking forward to seeing how not just discussion of TPUs and TensorFlow continue to increase, but how the data science community continues to find great insights in their spread. So if you're interested in seeing TensorFlow 2 at work on Kaggle, come check it out. Try out the code that Phil just showed you, compete in the Flower competition, or try it out with a data set of your choice, or try it with our past competitions, or on our hosted notebook platform where we give you some TPU hours to play with. In the coming months, we'll be launching even more competitions, so you can leverage the power of TensorFlow and TPUs on Kaggle. Now, it's been a big group effort. I want to give a special thanks to Martin Gorner, who is the DevRel project manager, who led the effort to integrate TPUs. So thanks so much to him for his hard work. And it's pretty awesome to see how easy it is to use TensorFlow and Kaggle right now. And so finally, thanks to you for joining us with our session today. Thank you for your time. Please come visit us over at the Dory. We'll be hanging out all week, answering any questions you may have about TPUs and TensorFlow on Kaggle. And again, thanks so much. Have a great day.